Okay, so here's a connected particle question that's a little bit different. So first thing we're going to do, as always, is draw a diagram. So we've got a van and a trailer going up a hill. And this is inclined at 12 degrees. So we've got our truck. And our truck is pulling a trailer. Okay, so the trailer weighs 250 kilos and our truck weighs 1200 kilos. Truck being pulled by a force of 12,000 newtons. And the resistance and motion of the van and trailer models as being a constant, so that means they've got some force slowing them down. And it says the van and the trailer are accelerating at 5 meters per second per second. Right, so the first thing, work out the total resistance to motion of the van and trailer. So the important word in that question is total. So we're going to look at the whole system. So first thing I'm going to do, I'm going to pick my direction, which is up the hill, because that's where everything is moving to. So I've got the 12,000, that's taking up the hill. And I've got the two gravity vectors pulling it down. So in total, I've got 1450 G acting at an angle of sine 12. Now, what have I got? Stopping end and hill. Also got friction, which they said was a constant. And then that is equal to mass times acceleration, which is 1450 times acceleration of 5. Great. Okay. So let's type this up. If I do this, I get 12,000 minus 2954425 minus frictional force is equal to 7250. And then when I solve, my friction comes out at 1,800 newtons. Okay, so that is A taken care of. Okay, now SDB. Given that the resistance to motion of the van is 3 times the resistance to motion of the trailer, work out the tension in the total. Right, okay, so we're just looking at the trailer now. So if the total resistance for both of them was 1,800 newtons, and the ratio is 3 to 1, that means I have to divide 1,800 by 4 to get 450 newtons. Okay. And it says that it's the van that's 3 times the resistance to motion of the trailer. So again, let's think about this in terms of a diagram. Okay, so here's my trailer being pulled by tension and being stopped by friction, and it's got its weight vector. Okay, so going up the hill, I've got T pulling it, I've got friction slowing it down, and also the weight vector. Okay, and that's equal to its mass 250 times acceleration, which is 5. Okay, so that's T minus 450. That's now 1/4 of the total frictional force, minus 509,384, and that's equal to 1,250. So I find that tension is equal to 2,210 newtons. So that's now B taken care of. Right. Now, when the van is traveling at 8 meters per second, the tow bar snaps. Okay, so something changes. So I'm assuming the resistance motions remains unchanged. Work out the time taken for the trailer to come to rest. Okay, so what I'm going to do, because something's changed, I'm going to draw a diagram again. Okay, so my trailer still. Now that's broken, but I've still got my frictional force and I've still got my weight vector. Okay, so now again I'm going to resolve up the hill. Now I've got nothing pulling it. I've got my frictional force of 450 trying to stop it. I've also got my 250g sine 12, my weight vector, and the only thing that's equal to is mass times acceleration, which is 250a. Okay, so then when I work that out, I find that a is a negative number, of course, because it's slowing down, because all the forces are pulling it back. So a is minus 3.84. Now, it wants to know how long it takes to slow down, so I need to link those together. Well, I'm going to use v equals u plus a t. Okay, it's going to go to 0. It starts at 8 meters per second. I've got my acceleration of 3.84. That's the t that I want to know. And when I work out t is equal to 2.09 seconds. Okay, so as we said many times, the key to success with these things is drawing a diagram and making sure we include all the forces. So the first thing we do is we do our diagram. Okay, once we've got a diagram with all our forces on it, the next thing we have to do is pick the direction we're resolving in. Make sure that the forces are in the right direction. So one going up the hill, positive. The one pulling down the hill, negative. That will stop us making sign errors. Then we need to think about what information from SUVAT we've got. And then we think about which equation, like this down here. I pick V equals UAT to link the things I had to get my solution.